Okay, so such that f of x equals 1, so where the y value is 1 there is at minus 3 pi over 2. Right there, yep. So cosecant is 1 over sine. Sine is an odd function,
Mhm.
so it's negative of the value that's there. So negative 7 over 6.
Cool.
Secant is an even function, so it's the same output minus 4.9. Negative 4.9. So this one now it needs to intersect the curve, so go up or down with that until it at least hits it once. Like there's good. That's great.
Yay, one homework done. Okay. M6, S2. Sorry, I'm gonna try to the next one that I have to do. I have a list, but it's just graph cotangent functions. There it is.
Hang on just a second. I'll be right back with you.
That's fine.
All right, I'm back. So a point not in the domain is like at 0. You can drag it over to the 0. Yeah, right there. So where it equals 1, so you want to drag that point left until the y value is 1, which I mean, keep going. Yeah, keep going. Left, 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 left. Yep. Keep going. You got to
Also,
keep
like,
going up
oh, okay.
till the y value is 1. There you go, right there. Same thing with the other one,
Okay.
I guess.
Oh, the heck, that's easy. Hmm.
Okay, so does forward 5x does the graph cross the x-axis? So that's at the minus pi over 2 and pi over 2. Not in the domain. It's like 0 is not in the domain.
Can you explain that real quick? Like why 0 like wouldn't be in the domain? Is that because they're like, can you just explain that real quickly?
It's not a quick thing, but like cotangent is really the reciprocal of tangent. Tangent is or let's do it differently. Cotangent is really cosine over sine.
Mhm.
Okay, and sine is sine of 0 is 0, so it's undefined when you divide by 0, which is
Oh,
where which is what's going on there. And it's periodic, so you can see it happens at pi or 2 pi. There's a bunch of places there that it could happen.
Okay, got it. Yay, another one done.
Okay. So like the quickest way to do this is to use a calculator, um, which is all I'm going to do to answer this. There is, a way to do it by hand, but that's not what we're trying to do today. Um, have you tried, are you familiar with the Desmos scientific calculator?
Desmos, yeah.
Not the graphic, this the actual, they've got a regular uh calculator that's pretty good. Yeah, there you go, that one. So what's nice about this is you can enter it the way you see it. So if you could split screen it if you want. I can enter it as well. I just need to see it. So that's the biggest deal is being able to split screen, go back and forth to see it.
Can I can I split screens on my end or is that for your end?
You can split screen. Yeah, no, that's, I don't want to get too technical on you, but it does work. So the thing is you get an answer and then you might have to compare to um the given answers.
Oh, okay, okay.
Um, so it, the answer here is negative square root of 3/3. So same kind of idea here is you can use a calculator to put the answer if you want. That Desmos one's pretty good. I also use Wolfram
Okay,
Alpha a lot,
okay.
and it just there are ways to do this by hand. So
Oops, what I wanted. Point zero four. What the heck? Does it
so
make
on the
a
right,
difference if
so
I put
see where there's the kind of your answers show up on the side. There's a little arrow. Hit the fraction thing there. It'll convert it to a fraction for you if it can.
oh, is that all of these? How many more do I have? Okay. Sorry, I forget that you're on the screen. I don't mean to be moving it so much. Sine, tangent. Would you rather me just stay on one screen? Is that easier?
Doesn't matter to me. I mean, I'm just here to help you get through this. We talked about what the expectations were. So
Why does um did this give you a different answer? Because I got this unless I put it in wrong, but I don't think I did. Sine tangent of -1, -7.
that's where you have to enter the answers one by one to see which ones are the same.
Okay. Um, do I just type? Oh, okay. You mean like put the answer in like where like the -7's at?
No, those answers like root 2/10, negative root 2/10, 7 root 2/10.
Oh, okay.
Well, you need to leave that one in there so you can compare it to them.
Oh,
You can undo. Well, okay, it's fine. Uh, and then you can just hit enter. Uh,
Square root of 2/10.
So
So
like
pretty
I would
much.
try this. I would try the -7 root 2/10 next.
Okay. -7.
There you go. There's the answer.
Oh, okay, okay. Um,
This is one you can also you could maybe use that calculator for.
let's see, sine of -1.
The way you're doing you'll speed this up if you can split screen this on your side. You know, if you have the so you don't have to go between tabs. Are you familiar with how to do that on the Apple?
I think I can just, if this one can move. I think, oops, not what I wanted. With split screen with the Desmos or with,
You're like when you have to go back and forth between tabs, it's very time consuming. Like as a it's like it's you can get the Desmos on like the right side and your Newton on the left or vice versa. That will speed this up for yourself.
okay, yeah, I got it.
I'm currently only seeing now the Newton, which is fine. But that's just, I'm just trying to give you some options to get through this, faster.
Yeah, let me see if I can have you see the,
You may have to reshare your window. That's another um, thing there.
okay, can you see them now?
Yeah. Yeah, that's okay.
Sine of
So
-1.
cosine. And this is where it's in parentheses, cosine of 405.
Like that?
Yep.
Okay. 45. Does that seem right? 45?
Yeah.
Okay. Yay. Let me make this big real quick. What was that? Composing functions. With these ones, should I put them into Desmos too?
I would graph this. Yeah, that would be the fastest way to do it. So if you want to split screen again, this one you'll need the graphing, calculator. So graph y equals sine x.
Y equals sine x.
Yep. And then the next line type y equals minus square root 3/2. So you can either use the keyboard down there for that, or type sqrt. So all right, and then you're just looking, you're clicking on those intersection points.
Mhm.
Um,
Oh, am I just looking for like ones that I can find on here?
yeah, that's kind of the nice way of doing it.
Okay.
Um,
Mm. Let me, not what I wanted. 4 pi over 3, 5 pi over 3, 0, negative, no negatives, 10 pi, 11 pi. Would it just be those two then?
It looks like it, yeah.
Mm,
All right, so this one we'll have to do a little bit more effort on, but you're gonna do the same thing. You're gonna graph y equals 2 plus sine x. Now, do you know what a curly brace is?
no.
Okay. It will really help if you can find the curly brace on your keyboard.
Oh, is it that thing?
That's a twiddle tilt. No, yeah, no, a curly brace is above. Usually it's next to the bracket where it's on the same key as the bracket. Yeah, that's what we want, but put that up in the previous one after the sine x. Nope, nope, I know, after it. So
Okay.
okay, yeah, so put the curly brace there and type in zero
Mm-hmm.
less than or equal to x. It's that one, yep. X less than 4 pi. Good. So if you're wondering where I got that, that's from where it says on the left there, 0 less than or equal to t less than or equal to 4 pi. Then in
Okay.
the next line, you can go down to the next line here and type in y equals 2. Get rid of the curly brace. Yeah, perfect. And then now you just want to figure out click on anywhere it intersects. So that's at 0, pi.
Oh. Oh, it's not even going. What the heck? Oops, that's O. 0,
Pi.
2 pi.
And looks like it's 3 pi is the next one. So that last one does not count because
Okay.
it's not included.
So it just stops at 3 pi.
Yes.
Hold on, let me see if I can get out of this thing. Ugh, I guess I can't. Okay.
All right, so you can do the same thing when you graph it here. Split screen it again. So you don't want here, click the undo button. You want to get out of the habit of deleting those because you can just you'll save some time by just editing. Like you want to do y equals tangent x,
Mhm.
um, just editing that and then removing the rest because you still want to go from 0 to 4 pi. So
Okay.
remove the plus sine x. Yeah, you have to remove the sine
Oh,
x
that's
there.
minus 2, right? Sorry.
Yeah. Okay. And then you go y equals 1. And you're just looking for the intersections there. Pi over 4, 5 pi over 4, 9 pi over 4, 13 pi over 4. You may, and go out to the right, I guess a little more on your graph, maybe. I guess, yeah, you got them all. Good.
Okay, cool. Oh shit, they're gone. What did I say? Pi over 4, 5 pi over 4, 9 pi over 4. Would this one be what I would put in like for the top bar for the
Yeah, you put in a sine x minus 1/3. And y equals 1/6. So you might zoom in on your graph a little bit. Yeah, there you go. Just as long as you can see it, got to get sometimes what it does is it grabs like X intercepts. So I would zoom in. I'd hit the home button there, house, just to make sure you're actually getting the the true intersection points.
Okay.
And that looks like it, just you gotta be careful.
It's this first one. Pi over 6.
Mhm.
5 pi over 6. $13. And it stops at 13, right? Do I count the last one?
Yeah, you want to keep going. So when we restrict the domain with that 0 less than x less than 4 pi, you want to grab all of them.
Oh, okay.
The reason we didn't on that first one is it really was right there at the end. Like if the answer is 4 pi, you exclude that because it just says less than, it doesn't say less than or equal to.
Nice. Oh, that's the one we just did. I think this one we started.
Okay, so the same thing here. You're gonna split screen it, and you're gonna graph secant. So this time you can delete that first thing, yeah, altogether. Yeah, you can do y equals secant x,
And then x would just equal to.
y equals 2.
Oh, y.
They're both y's, yeah. And then you you get like want to get a sense for like pi over. So all the answers are positive. So everywhere you're clicking is negative. So you might want to unclick those, yeah, and just look. Okay, there's pi over 3, 5 pi over 3, 7 pi over 3.
Pi over 3, 5 pi over 3. And I think it's just those two. Pi over 3. Yeah, because there's no 7 pi over 3. Oh, shit.
All you gotta do is change that. So this one this is where you'd use those curly braces again. 0 less than or equal to x inside the curly brace to 2 pi.
So y would equal like.
Secant of x, you see, that was fine. And then curly brace. 0 less than or equal to x less than 2 pi.
Less than.
So what that does is, and then now you type in y equals minus square root of 2. And then now you just have to find the two intersection points or whatever, however many there are. And those are your answers. You don't have to worry about um, whether you're missing them or not. All right, good.
This one
So,
would be like the same thing, except I would
yep,
change this one to cotangent.
that's right. And then square root of 3 over 3.
Square root of 3. Oh, it's not on here. Oh, wait, pi over 3. Yes, it is. And 4 pi
4
over
pi
3.
over 3.
This one's just tangent, right? Like nothing else with
That's
it.
right. Yep.
And that stays the same. And this is just -1. And you said like not to count the like this, like I wouldn't count this 0.
Well, it doesn't hit the curve there.
Oh, okay.
There was one where it did hit the curve at the right end point, which was excluded.
Okay.
Yeah, it was like the exception in the first one we did, which was weird, but all right, good. So even though this one's more complicated, it's the same thing. You're going to type in Y equals, yeah, 3 secant x plus 2 square root of 3.
3 secant x. Oh, so the whole thing. And I don't need the brackets for this, right? Or
You should, yeah, you do, because it's 0 to 2 pi.
oh, 3 secant x plus 2 square root of 3. Okay.
And this time it's y equals 0. So that's the other side of the equation. There you go. 5 pi over 6 and 7 pi over 6.
What the heck is this with you? 7 pi over 6. Why did it? Was that right?
It looks good.
Okay, cool. Just want to make sure.
Yeah, I am following along.
Okay.
You figured out the recipe here for doing these.
Yeah. Cotangent equal to 'Mm, oh, there it is. Tangent theta. Oh, that's not what I wanted. -1. 5 pi over 4. I have a question. It's kind of for like trig overall. And do you know in calculus, is there a lot of like trig in it, or is it just like a little bit? Like if you know.
Depends on the instructor for calculus 1.
Okay.
Could be very minimal, could be a lot. Mostly it's unit circle, knowing your unit circle.
Mhm.
Um, Now if you go into like business calculus, no, there's no trig.
Okay.
Um, Calculus 2, yes, there's a lot of trig. And most students struggle because they never really learn it.
Mhm. Okay.
And that's not a criticism, it's just that's the reality of what it is.
Yeah.
Uh, so um,
Yeah, because the calc that I have to take is just like calc 1, but it's more for like a science major. So I was like, I don't know if I'm gonna see a lot of this like in it again.
it's always best to check, rate my professor, talk to friends, see who they're taking it with, find out, path of least resistance. Um, there's variations on it. You get good teachers, bad teachers, ones that, we shouldn't take.
Yeah.
So just to keep all that in mind. This is the same way you're going to graph the 2 cosine x minus 3, 0 to
Okay.
2 pi.
And then the y is just a -5.
That's right.
2 cosine x.
Minus 3.
Oh, -3. Okay. That makes more sense.
Yes.
So just pi. Mm. Square root of 3 plus 2 square root of 3. Pi over 6 and 11 pi over 6. Yeah. Mm.
The same thing. Yeah, just you're gonna graph -4 sine x plus 6,
Okay. And the y
y
is
equals 2. Yep.
-4 sine theta plus 6. What the heck? Oh, pi over 2. Stupid. Right? Yeah, pi over 2. Mm,
You're gonna
so
graph 8 sine x minus 8.
8 sine x minus 8 and y is
Good.
equal. That's the 4 square root of 3 minus 8, right?
Exactly.
3 minus 8. If it's undefined, do I just put like 0? Did I put that in right? 8.
No, you did not. It's 4 square root of 3 and then
Oh, okay.
x. Yeah. And then go to the right and then type right arrow -8.
Oh, pi over 3, 2 pi over 3. Exact answers. Um, okay. Pi over 2 and 3 pi over 2. Pi over 2. Hmm. With this one, does it matter how I write it or?
And just follow what it has there, 1 minus 7 cosine x and then 8 for the second one. So basically to answer your question, you just want to follow whatever they have in there.
1 minus and then is equal to 8, which is pi. Ugh. Cool. We're done with that. Mm. It's the same thing, right? You just plug it in.
Yep. You don't need the curly braces this time. Although they
Okay.
might help. Actually, I would leave them in.
Okay.
To tell you if there's a problem where they shouldn't be in. It will help you to limit that.
Okay. We can add
So that needs to get out of the root there. Yeah.
2 secant x plus 6.
Good.
Pi over 4 and 5 pi over 4. Mm,
Keep doing what we're doing. I'll help you convert the answers. There'll only be one here.
4 secant. Do I still have to put the x in parentheses or no?
Do not.
Okay.
All right. So there's it's just there at 0. So that's the only answer. So 2 pi is 360 degrees, but it's excluded. So
Oh,
it's
okay.
just at 0.
Mm. Oops, didn't want that. Square root of 3 cotangent x minus 3.
So you get, it's under the root there. You want to get that out of there.
3 cotangent x minus 3. Mm. 3 square root of 3 x plus 5.
Nope, nope. Yeah, no, that won't. Yeah, you got to, that cotangent, you got to go to the right of it. Yeah,
Keep on forgetting that it doesn't like automatically just like kind of pick
it
it
does
up.
not. Yeah. Remember, you're getting the answers here very fast. I mean, you've done like a lot of assignments here in a short amount of time.
Yeah. 5 pi over 6. Oh, wait, this one's in degrees.
Yeah. So here's how you convert. So when you go to the Desmos there, go to another line, type in 5 pi over 6 times 180, go to the right of it. Uh, just go to the right. Yeah, like not there. That no, no, to the right of the fraction. Times fraction.
Ah, not what I wanted. Goodness Christ. Times 180.
180 over pi. Yeah. And
No.
then that's 150. Now the other one, all you have to do is edit that line. So go find the next one, next intersection point. You want to stay on that page. That second one there is 11 pi. So change the 5 to an 11. There's the other one.
Oh, okay. This one's gonna be the same thing. Negative 7 secant x plus 7. And that's still 14. Pi. If it's just pi, isn't it just like 0?
180.
Oh, just kidding. Let's see. 4 square root of 3 secant x plus 7. That's a minus 1. Probably going to be, what the heck? Did I put it in wrong? 4 square root of 3 secant x plus 7. This is minus 1.
Hit the home button.
Oh,
There you go.
no wonder I missed it. 5 pi over 6 and 7 pi over 6. Oops, not what I wanted. 210. Negative 7 tangent plus 4. That's a minus 3. So, oh, that's going to change.
You just edit the bottom, just change that.
Pi over 4, which would be 45. And 5 pi over 4. 225. Oops. Almost done. -6 square root of 3 cotangent of x plus 1 equal to -5. Yes. Oh, it doesn't even want it in degrees. Pi over 3, 4 pi over 3. Oh, wrong thing. Pi over 3, 4 pi over 3. Oh, another one done. What was this one? Solving single line. Mm. Do the same thing, right? Just plug it in.
There's a small variation. Yeah, it's a small variation on it. It's gonna be slightly different, but yeah, go ahead and try this.
So, oh, that's a 2 times x.
Yeah, that's where you might start using parentheses, sign parentheses 2x. Close parentheses. And then 1/2 there. All right, so now there's a bunch of angles there. Pi over 12, 5 pi over 12, 13 pi over 12, and so on. Then there's one more.
Pi over 12. 5 pi over 12. Pi over 12. Hold on, I literally can't see anything. Okay. Did this one? Pi over 12, 5 pi over 12, 13 and 17, yeah.
It's the same thing, be sine of 3x. Cosine of 3x, yeah.
Ooh, cosine 3x.
And then y equals 0.
Pi over.
Like it's that last option there. All right, I'm gonna just ask that we stop here for the hour and take a short break. There is a new booking email for that next hour. So just be sure to click on that. But let's stop here and we'll resume in about 10 minutes.
All right. Thank
Thank you.
you.